All right. So this is, as I said, Betterbee Seasons of Beekeeping Spring course, or really a version of that course, which we've now decided to offer freely to anybody like you who wanted to sign up. So just a little bit of housekeeping. As I said, Elizabeth Warner is our education coordinator here at Betterbee. That's her smiling face. So she is in here and is able to monitor some things, make sure things run smoothly. And importantly, she's going to be the one handling our Q&A session, or rather sort of moderating it and making sure I get all the questions that I need to answer. So you will note in your Zoom window, there is closed captioning available. That is provided by Zoom, and I cannot vouch for it. I don't know that Zoom's AI knows what a Varroa mite is, so I don't know what they're going to close caption some of these words as. But if you would like to use that is available to you. If you have any questions at any point during the lecture, I'm not going to be able to see those questions until we get to the end, but I am perfectly able to answer as many questions as we've got, at least until our 8:30 cutoff time today, if it gets that far. So use the Q&A feature inside of Zoom and just type in a question. Elizabeth is going to be keeping an eye on those, and she might get rid of questions that are duplicates or answer a few of them by typing just to move things along. And then the questions that build up over the course of the lecture, I'm going to do my best to answer when we get to the end of it. So with the housekeeping out of the way, I should probably tell you who I am. I am David Peck. I'm Betterbee's Director of Research and Education. I'm basically the staff scientist here. And so my role, my job is multifaceted, but it involves product research, it involves teaching classes, giving lectures like this, and it also allows me to do some of the scientific research that I started when I was a graduate student and a postdoctoral fellow at Cornell. So I worked with Professor Tom Seeley, who is a world-renowned expert on bee behavior. And I bring that behavioral biology perspective to my beekeeping and my bee education. So understanding the bees and what they're doing and why they're doing it also makes us better beekeepers. So what we're talking about today is spring. And I've put spring here in scare quotes because spring can mean a lot of things to a lot of people, and it happens at different times in different places. So in Greenwich, New York, where I live, where I keep my bees, where Betterbee is located, spring is a season that happens roughly from about mid to late March until early May, most of the time. And that can vary depending upon the season. Throughout this lecture, I might occasionally reference months or times of year, and if that happens, I'm going to try to put anything that is really locked into what we're doing here in Greenwich in this green color. So if you see something in green and you say, hey, that's not what my April looks like, I know, I recognize that we're all beekeepers in different places. But the general principles we talk about are going to be roughly similar. It's just that you're going to have to adjust if you live in Maryland or if you live in Quebec. Things might happen a little earlier or a little later in the season. So what is spring beekeeping? Well, we can start with the bees. There are two places where bees might be as you get ready for your next season of beekeeping. Some of them might be bees that you don't have yet, bees that you've just purchased. Maybe you're a brand new beekeeper, or maybe you are not a brand new beekeeper, but for one reason or another, you've needed to order new bees. So those bees are going to be coming to you at some point this spring, and you need to get them settled and you need to get them set up to succeed. Other beekeepers who might not need to buy bees are going to have overwintered colonies that have made it through winter, but they're going to need help going through that transition and getting themselves also set up for growth and success. And so we're going to talk about both of these so that everybody in either context is going to have the information they need. So we'll just start very briefly with new bees. Whether you are buying a nucleus colony of bees, or a package, you need to get them installed into the hive. You need to make sure the queen is laying. And if you get them from Betterbee, we'll give you instructions. If you get them from anywhere else, they'll probably talk you through the process of installing them. But then once they're in and established, and once you're sure that queen works, the goal is going to be growth. Spring is a time of growth for bees. And so growth is measured in brood, and growth is fueled by food. So as long as you've got a good a good colony and good queens, you're going to achieve brood growth, brood population increase, and therefore bee population increase, as long as there's enough food for the bees to fuel all of that. And so that food might be honey, that food might be nectar coming from flowers, and it may occasionally need to be supplemental syrup. If you're a new beekeeper just getting a new colony started, especially if they're starting without any drawn comb, then you need to pay particular attention to the need to feed them, because those bees need to build a whole lot of beeswax combs, and beeswax is an extraordinarily costly material for bees to produce. These are some photos that show some bees that have been, graciously offered to let us see their undersides so that we can examine those little wax scales that they are producing from those wax glands in the bottoms of their abdomen. Those bees are producing that wax by eating huge amounts of sugar, either in the form of nectar or in the form of honey or sugar syrup that a beekeeper has fed them. Beeswax is made, to greatly oversimplify the chemistry of it, by taking things like fructose, glucose, these sugar molecules, which are a whole bunch of carbons arranged in a ring, breaking them apart, adding some bits, chopping some other bits off, and creating these long chains of hydrocarbons. So these long carbon chains with hydrogens and occasional other things attached to them. And so right here, we can see one of the major esters that forms beeswax, and we need to understand just how much sugar needs to go into making each and every one of those wax molecules. I have done a deep dive into the literature to try to figure out how accurate this estimate is, this idea that you need 8 pounds of honey to make 1 pound of beeswax. And the research is really variable. It's hard to really nail this number down, but it is very clear from every time a scientist has tried to study this and get a number out of it, a lot of nectar, sugar, or honey is required in order to make any appreciable amount of beeswax. So, as we are helping our colonies grow, especially if those colonies need to make wax, which is typical of new colonies, often we need to feed our bees sugar syrup in order to facilitate that wax production. We need to give them some sugar that we're going to invest now from outside of the natural system that's going to allow them to build all of their infrastructure, all of that comb that will let them grow and grow and grow throughout the season. So what if I have overwintered bees? What if I'm not worried about, buying a new nuke or a package? What if I've got bees that have made it through the winter? What does spring look like for me? Well, in many ways, it looks exactly the same. The thing that your colony needs to do is grow into the spring and summer season. And the way that they are going to do that is going to be fueled by food. And so if they need supplemental food, you will give it to them. If they've got any honey left over from the winter, that can be a great head start for them. And as the flowers begin to bloom, they are going to start to be able to collect nectar and pollen that will grow and accelerate the growth of that colony. So as beekeepers, what do we need to do? How do we assess a colony that has just come through the winter? How do we evaluate them? Well, the first thing to do is to understand that the first inspection of your colony is not going to be a typical inspection. The first thing that you should plan on is a brief spring inspection. And for this, you are looking for a period of time in March or April in my neck of the woods, where the temperatures are going to be somewhere in the 60s, a lucky day, like we just had around here. So I just did my first brief inspections of my own colonies at home and figured out, all right, how are they doing? Who's alive? Who's dead? Who's strong? Who's weak? Who has too much honey? Who has not enough honey? Trying to get those basic pieces of information. So what you ask first is, here's a hive. Is there a live colony of bees inside of it? And if the answer is no, then you need to do a dead-out analysis. And I'll talk about what I mean by that in a moment. If that colony is alive, you also need to try to figure out if they're in crisis. Are they having queen problems? Are they having brood problems? A very large colony is probably telling you that they're doing all right, but a colony that seems small and like they're struggling, they might need a little bit more attention to figure out what's going wrong. You need to figure out if the colony is very close to starvation, because unfortunately, although we would like the weather to stay in the 60s as soon as March rolls around, it rarely does. So those bees are going to need more fuel to get them through more cool weather, and we need to make sure they're not about to starve to death and don't need some supplemental food. And you also want to check your equipment. Now is a great time to notice, hey, that box has a hole in it. Why don't I order a new box now so that I can get a new box ready to swap in when I go and really start working this colony, next time I get to do a thorough inspection. You might also consider doing some spring Varroa mite treatments. And you're also going to need to consider what feeding your bees might need from you. So we're going to talk about each of these things. All of these things either just happened or should happen the next time you get a chance to go out into your colonies. And I just want to talk through the different steps that go into this. So that first spring inspection, as I said, it needs to be brief. If you have the opportunity, you might pull a frame and look for eggs or look for brood, try to get a sense of whether the colony has open brood, whether they've got capped brood, but you need to be extremely brief if you do this. Often I'm not going to trust myself to be as brief as I need to be, so I won't even pull those brood frames to look at them. You can examine the colony for honey and pollen stores. Honey is pretty easy because if you have to lift a big heavy box to get into the colony, then you know that they've got some honey stored there. Pollen is a little harder, but often just by peeking from the tops and bottoms of the frames without removing them from the box, you can get a sense of whether there's any pollen kicking around. You might consider inspecting your colonies by box instead of inspecting them by frame, or at least more by box than by frame. And what I mean by that is if you pull a frame here and there, it might give you some information about the hive. But often, if you've got a colony in 2 boxes and you lift up the top box and look at the top, look at the bottom, look at the top of the box below that, maybe even the bottom of that, if you're going down to clean your bottom boards, then that's going to give you a lot of information and it won't require you actually taking apart any structure or cluster that those bees are in. If you need to feed your colonies and the weather is right, your hope is that you can start feeding them thin or light sugar syrup. So if a colony does not weigh enough, you need to get ready to feed them sugar syrup or some kind of dry sugar if the weather is going to be very cold for the next few weeks. If you've got mouse guards in place, and you should, because otherwise you might have mice inside your hive, but if those mouse guards are in place, now is a perfectly reasonable time to remove them. Even if there are mice coming and going and the bees are occasionally going into winter cluster, it's uncommon for a mouse to come in and invade a hive in March or April. And you also want to take this opportunity to clean your bottom boards. Rarely will a colony weigh less than right at the end of winter. And so if you have to lift everything off and move it around and scrape those bottom boards clean, now is a good time to do it. And odds are pretty high that under a healthy colony, there's still going to be a lot of dead bees and other detritus from the winter. And instead of having each individual bee have to go down and grab a mouthful of dead bee leg and carry that outside, it's helpful for you to grab your hive tool and just give it a quick scrape. And if you're interested in your Varroa mite levels, and you should be, and you have a screamed bottom board under the hive, now might be a time to stick in a sticky board, an oil-covered board that's going to help collect those mites and give you an opportunity just to roughly assess whether or not you've got a Varroa problem or how bad it might be. Early spring is the time that the bees wake up. It's the time that the beekeepers can go outside, but it's also the time that bears are waking up. They're coming out of hibernation, and typically they're doing so very hungry. And so it's very important in this early spring brief inspection to also make sure that your electric fence or any other bear protection that you've got is working and up to snuff. Because the last thing you want to do is nurse that colony through the spring, help them grow and have a great start ahead of them, and then have a bear meander through the apiary and eat your colony. Also, this is a good time to clean out winter trash because you're doing less with each of your hives because you just can't take them all apart and do all those manipulations when the weather is still a little chilly. And so since you're going to be up in the apiary anyway, why not have this be the opportunity to grab any garbage or old equipment or things that have broken down, haul them out, do whatever maintenance you need on your fence or your gate, so that when you come back to the apiary and are ready to do some real bee work, you're not distracted by all of those chores. So during this inspection, hopefully we're going to find lovely, happy bees. We're going to talk about all the great things that we can do to help those bees going forward. But sometimes we don't find that. Sometimes we find a dead colony. And this can be a very sad experience. It's a very difficult experience. There's a lot of recrimination and guilt that we sometimes feel. What did I do or what didn't I do that could have contributed to this? But deadouts offer us two things of extraordinary value. One of them is resources. Inside of those dead colonies, there is going to be probably some residual food, and there's also going to be the comb that dead colony was living on. And those are resources that could be of great value to another bee colony. A deadout also contains knowledge. or rather they can give you knowledge about why those bees died. And if you can figure out why the bees died, it's going to make you a better beekeeper, and that's going to help your other colonies even more than that food and that comb could. But it's important to get all of that knowledge before you start using those resources. So it's worth the time, as soon as you realize that a colony is dead, to do this dead out analysis, to analyze what's going on and try to guess why that colony didn't make it. So we are going to do a necropsy. We are going to go into these dead colonies and try to figure out what might have gone wrong. So there's some quick questions we've got to answer. Are there any bees here? If there are none, that tells us something different than if there were, a bunch of them. Is there an organized cluster of dead bees inside of the hive? And if so, how big is it? Is it the size of a grapefruit or the size of a basketball? Is there any brood present inside of the hive? Is there any capped brood in here, alive or dead? Probably dead if the colony has not died very recently. Is there any honey present in the hive? Do they have any food? And if so, where is that food relative to the bees? Is there any sign that the bees have had bathroom accidents inside of the hive? Any fecal staining on any of the frames or combs? And is there any follow-up testing that might be available to me that I can do? Is there a bee lab that I can mail some samples to that might be interested in or willing to help me analyze this? Or do I need to get myself a microscope so that I can take some smears and try to figure out what else I might be able to get from my bees? If you have the ability to do so, it's not a terrible idea to take a sample of bees from a necropsy, just in case you start thinking, hey, I wonder if it was this disease, or I wonder if it was that pesticide, or something like that. Having those bees tucked away in a freezer somewhere could give you something to test later. So what do we do when we're looking at a dead out? Well, first, there are some things that people get very worried about that probably don't warrant that much worry. So if you find dead bees out in the snow or in the grass around your colony, if you've got brown or yellow spots of feces like this around a colony, if there's stains on the surface of the hive, people often will get very concerned that that colony is in big trouble. And realistically, this could just be some slightly sloppy bees going out, relieving themselves, and then coming back in. You might get a few drips and drabs that fall on the entrance to the colony, and you will see sometimes quite a lot of staining from a very healthy colony with a whole bunch of bees that just finally got that first chance to take a bathroom break. The other thing that often causes a lot of concern is when beekeepers look at their hives in spring and they find a whole lot of dead bees out in the snow or on the grass in front of the hive. This is actually sometimes a very good thing, but beekeepers don't see it that way. We know that when our colony comes out of the winter in the spring, they are obviously not going to be as strong as they were going into the winter in the fall. There are going to be bees that didn't make it. And so if that colony is able to mobilize its workforce and send them down to pick up the dead bees and toss them outside, that actually means that your undertakers are doing their job, that the colony is functioning normally. So dead bees outside of a colony on a warm day actually tells you that things are probably going pretty well inside. So as we go into this dead colony, there are some cues that we might look for, some things we might examine. One of them is finding evidence of this sort of brown or orangey brown bee feces, poop, on the frames. So what this is dysentery. And dysentery is not a disease, it's just a symptom. So when bees poop inside of their hive, we say that's dysentery, and that can be caused by a few different things. It could be that this colony has a high level of ash in their diet, a high level of minerals in the food that they're eating, or it could be that there's a very high level of moisture. Both of those can make it hard for the colony to basically hold it in, and so it's going to increase the likelihood of bathroom accidents. It could also be happening because the colony didn't have a winter exit. They were unable to get out of the hive to relieve themselves. It could be a sign of Nosema apis. So Nosema apis is one of two Nosema diseases that colonies can get. The vast majority of colonies in the United States nowadays have Nosema ceranae, a different Nosema parasite. But Nosema apis is the one that got a reputation for being associated with dysentery in these colonies. Nosema ceranae often does not cause dysentery or anything similar to what we saw from a Nosema apis. So this shouldn't be your first thought, but it is something that you should keep in mind, the possibility of some intestinal disease that could have caused your colonies to have these accidents. If you see a lot of bees that are dead inside of their cells, head first, huddled down in there next to one another, that can be a sign of starvation. That's not the only thing that can cause it. But when you see something like this photograph, a cluster of bees that have a lot of those bees in the midst of the cluster down into the cells with no visible honey anywhere around them, that is often going to be your clearest sign that this colony has starved to death, starved and then frozen. You may find abandoned brood in a deadout. What does that mean? Well, it could be that your colony starved. They simply ran out of honey. There was not enough to keep them warm, and so they all starved while trying to raise brood. It could be that the colony was diseased. They had some issue, some virus or other issue that caused too many of the adults to die before these brood could emerge, so there weren't enough adults to take care of them. Seeing brood often indicates that your colony made it much of the way through the winter. So that can be a really important clue about whether this was a fall death, an early winter death, or if it was a late winter and early spring death. Because colonies are not going to have a bunch of brood in the middle of December, at least around me, but they'll have a lot of it as they get to the other side of the new year and start beginning that build-up process. One thing that is not uncommon is to find a very, very small bee cluster like we can see on the right. A little bit of honey, even if it is nearby to the colony, if they're not in contact with it, they may have not been able to generate enough heat to mobilize themselves and move across that frame to get to the honey. This is typically not going to be what killed the colony, ultimately, because the reason that colony became so small is typically going to be some kind of a disease issue that caused too many bees to die and that cluster to get too small and get so small that it didn't have the critical mass required to stay warm in the winter. You may find other kinds of brood or indications of queen issues in a colony. So if you find drone brood, like we can see here on the left, that can indicate that perhaps your queen failed or was in the process of failing. Maybe she ran out of stored sperm, so she couldn't lay fertilized worker eggs anymore. Or it could be that she's died, and now you've got a few laying workers trying to get a little bit of reproduction inside of that hive using the stored pollen and stored honey that they were hoping to be able to make use of. But unfortunately, the population collapsed and the colony died before they were able to hatch out any of these drones. The other thing you might see is queen cells. If a colony is in desperate need of a queen because she dies in the middle of winter, they will typically start to make a queen cell if they can, even though there are very few drones flying around in February. It's unlikely that these queen cells will reach maturity. If they do, it's unlikely that they'd find a drone to mate with. But this can give you a sense that the reason that that colony died had something to do with the queen. And then, very importantly, there are some clues that you can find that will tell you that your colony may have died because of Varroa mites, which is a very common cause of death. So over on the left, we can see a few cells that have up at the tops of the cells. So we're looking from the bottom of this frame up towards the top of these cells. You can see a few of them have these little white speckles up on the top. And those white speckles are guanine, mite fecal residue that the mites deposit in these cells while they're reproducing inside. So if you find a lot of evidence of guanine in the cells, that can give you a clue that perhaps the most recent occupant of those cells was a developing bee that also had a bunch of varroa mites on them. Another thing you can look for is wing deformities or other signs that your bees may have had a Varroa-transmitted virus like deformed wing virus. And so over here, we have this bee that has clear wing deformities. That's like an indication that this colony may have suffered because they had high levels of mites. If you think that Varroa could have caused the death of your colony, it is perfectly reasonable to try to take a half cup of those dead bees and do an alcohol wash on them. Sample them for Varroa mites to see how many mites you can find. Now, this obviously isn't going to tell you the number of mites that went into the winter. It's not going to detect every mite because a bunch of dead bees in a pile sitting on the bottom of a bottom board is very different than a bunch of bees crawling around that you've caught for a proper alcohol wash. But nonetheless, if you wash the bees in your hive and you find 40 mites on a sample of 300 bees, that gives a pretty clear sense, even if that number is not perfectly accurate, that Varroa could have been a major contributing factor. Other things that you'll find in a deadout is that very frequently you will find moldy, wet, dead bees, and you'll also find moldy combs. There is very little information that you can get out of this. It is almost impossible for your colony to be killed by molds. There aren't molds that live in bee colonies that will overwhelm a normal functional colony. And yes, it is true that excess moisture in the colony can contribute to bee mortality, but it's also true that if any creature dies, they have moisture in their bodies that is suddenly going to be released. If I keeled over right here, I would probably release a lot of moisture into the rug of my office over the next few weeks, but that doesn't mean that the moisture is what killed me. So finding wet bees doesn't tell you that moisture was the problem. Finding moldy bees just tells you that mold grew on those dead bees after they died for some other reason. It is important when you're analyzing a deadout that you can tell the difference between some similar looking things. So for example, if you call me and you say, I found some white stuff in my cells, I don't know if you mean that you found some crystallized honey, some sugar crystals inside of some honey cells, like we can see on the left, if you found some moldy cells, like we can see up above, or if you found some of that guanine, that white residue at the tops of the cells that indicates Varroa mites. And so it's important to be very precise. And ideally, what you'll do during these deadouts is take photos or video so that you can refer back to it and you can share it with others if you want to get their assistance in figuring out what happened. So when we start to get these clues about why our colonies died, we can start to decide what to do with their resources. If there's any indication that your colony has American foul brood, any brood disease, or if they have clear evidence of nosema disease, which can be transmitted by those fecal stains, then we may not want to use those frames. In the case of American foul brood, you absolutely must not use it. In the case of nosema, it's probably a good idea to try to just get new equipment for your bees. Um, if you have honey in your colonies, that can typically be fed as is. Colonies that have extraordinarily high levels of virus that cause them to die do have detectably higher levels of some of these viruses in the stored pollen and stored honey in their hives, but it is almost never at a level that is clinically significant. More often than not, as long as a healthy colony is exposed to these resources, they'll make use of them and they won't be any worse for wear. Combs, very importantly, the wax combs your bees have built are extremely helpful for a new package, a new nuke, or a new swarm that you might try to install into this colony. And so don't scrape all of the wax off of a dead colony just as a matter of course because you feel like it's become dirty. If those combs are absolutely covered in mold, put them into a strong colony, and probably a day later, you can go in and not find a speck of mold on them. If there are signs of bee feces, those little drips and drabs of dysentery, if you've got your hive tool handy, it's not a bad idea to scrape any of that off. You can even scrape out bits of comb that have obvious fecal staining on them, but the bees will also clean that up as well. And you need to make sure if your colony dies that you don't go inside and spend the next couple of months mourning them, because while you do, all of those resources that have been left behind, all of that wonderful comb they've made, all of that honey that might be stored away is going to be found by robber bees or wax moths and destroyed. And so you need to make sure that you're able to remove all of those resources to somewhere safe so that you can then use them on other colonies. Now, here at Betterbee, we very frequently have lots of folks reach out to us about why their colony may have died. They'll send those dead out photos to us. And this is one that I just got today. And this is probably our most common conclusion is we look at a colony like this and we say, there's a very small cluster. They seem to have dwindled. There's a lot of dead bees inside. And talking to the beekeeper, we learned that their Varroa management was not at the level that we might have expected. And so our best supposition about what happened here is that this colony could very likely have died from Varroa mites. If they took a sample of those dead bees and did an alcohol wash, that might give us a little bit more information. So let's talk a little about Varroa and how our spring beekeeping can affect our Varroa population. So this is a Varroa mite, and they are really public enemy number one in beekeeping. These parasitic mites are devastating, parasites of bees. They go through sort of an alternation between these different phases in their lives. In the reproductive phase, they go into brood cells, they feed on bees, they suck the hemolymph, the blood, out of those developing bees, and they lay eggs, which then emerge, and then they incestuously impregnate their siblings, and now we've got more Varroa mites. In the other phase, the phoretic or dispersal phase, they're riding around on adult bees and they are sucking nutrients out of the bees' fat bodies. The bees that are alive in early winter but then eventually succumb are often bees who have had their fat bodies drained, because those fat bodies are an important part of helping a bee live for months through a long cold winter. And we know that the typical Varroa mite is going to go through a few reproductive cycles in her life, typically, somewhere in the neighborhood of three reproductive bouts. And these mites are, in addition to directly harming the bees, also transmitting viruses to them and between them. So there's a whole bunch of honeybee viruses that have been identified. There's probably a whole bunch more that we haven't identified yet. But of these, one in particular, deformed wing virus, or DWV, is a devastating plague on bee colonies. Over here on the right, we have a bee who grew up in a colony that had very high levels of deformed wing virus, levels so high that she actually has these characteristic wing deformities. It's important to understand that if your colony has DWV, but only at low or moderate levels, you probably won't see bees with deformed wings. It needs a lot of the virus during the bee's development to actually cause this. So just because you don't see a bee with crunkled up wings, that doesn't mean that you don't have deformed wing virus in the hive. So the typical bee and mite population dynamics look something like this. So if we look at this graph, we can see the yellow line shows the bee population starting in January, climbing up in the spring, reaching a peak, and then trailing off into the fall, and then going down to its minimum at the end of that winter, coming into the following spring. So that yellow line is pretty straightforward, and that should happen every year in a colony. The red line is the Varroa population here. And this gives us a rough sense of how this mite population, even though it starts low early in the season, can grow exponentially whenever those bees are raising brood. And so that mite population will climb and climb and climb and climb. And even though it also drops down as some of the mites age out or die of old age during the winter, you start the season with maybe a few mites and you can end it with thousands. And so the following season, we would start with thousands and end with who knows how many. Typically, we'll end with a dead colony. This is bad. That's unfortunate and harmful for our bees. But what's even more devastating than that red line is the space underneath it, because we can look at the area underneath that Varroa population curve, and we can look at it as sort of a proxy or an index for the total amount of mite feeding that has taken place as that mite population has grown and grown and grown. The more mite population, more mite reproduction that takes place, the more overall accumulated mite feeding will have happened in that hive, and the more virus transmission is going to take place, because it's when they feed on the bees that the virus gets transmitted. What that means is that your goal cannot be to knock the mite population down once a year. You need to continuously keep the mite population low. Because if we went in and killed all of these Varroa mites in September or October, sure, that red line might plummet down to zero again. But all of the harm that they'd caused in that hive during April, May, June, July, August, that's still going to be there. And that virus transmission could kill the colony, even if the mites are gone. So why are we talking about Varroa treatments in spring? Well, this is the time where your mite population is typically at its lowest. And what that means is that every mite that I kill in the spring is not going to have a daughter or a granddaughter or a great-granddaughter, and so on and so forth as that season wears on. So, here we've got a Varroa mite, and if we imagine that I fail to kill her in the spring, we might say that, if she's reproducing primarily in worker brood, if she has somewhere between 2 and 4 reproductive bouts, and she can have 1 to 2 daughters in every reproductive bout, we might conservatively estimate that that one Varroa mite is going to be able to produce 4 mature daughters. Those 4 daughters are then going to be able to produce, in turn, 16 new Varroa mites as the season wears on. And so just to emphasize this point, that merely looking at the great-granddaughters of that single mite that we failed to kill is going to look something like this. So it is very, very valuable to us and to our bees to kill our Varroa mites in the spring so that we don't have to fight nearly as many of them later on in the season. So there are a few different tools that you can use to manage Varroa mites. There are 3 sort of classes of products that I will mention here. One of them is formic acid in the product, in the form of the product Formic Pro, which is temperature dependent, and that can cause problems in spring, not typically because it's going to get above 85 degrees Fahrenheit, but because it is often going to be below 50 degrees Fahrenheit during that treatment. And so you need to make sure that you find a window where it is between 50 and 85 consistently so that your bees are able to manage the formic acid vapor, but let it kill their mites. There are a lot of products based on the active ingredient oxalic acid, and typically that is going to be most effective when you've got less brood in the hive. So getting those treatments in earlier is typically going to work better, just because the mites are sheltered when they're inside of the brood caps. And so we'll talk about a few different products that use oxalic. And then finally, you have Apivar 2.0, the new amitraz-based Apivar product. But you have to delay supering those colonies for 70 days after you put the treatment in. So here, as we sit in mid-March, if I count 70 days forward, I might not be able to afford not to put supers on my hive for that much longer. So I may have already missed the opportunity to use a product like this. A product like Formic Pro is pretty straightforward. It's simply these formic acid impregnated pads that you can put into a hive. And even if you live in an area that is classically too hot to use formic acid during most of the summer, that doesn't mean that you won't have a good window to use it during the spring. So this is a way to knock the mite population down pretty decisively. It does hit a colony a little bit harder than some of these other treatments. It will kill brood. It will kill, some of the weaker bees in the hive. But at the same time, it's also going to hit the colony and kill some brood at the time when they are most primed to making more brood and growing quickly. And so you would expect your colony to recover from this better than they might, at other times of year. Oxalic acid can be applied as a vapor using one of these battery-powered heat vaporizers or a plug-in heat vaporizer. These are safe to use with honey supers in place, as was the formic acid, but they do not penetrate the brood caps, and so they're only killing the phoretic mites on the outsides of the bees. You might need to do repeated oxalic vaporizations in order to effectively treat those bees. There's a relatively new product called Varroxan, which is an extended release oxalic acid strip. Oxalic acid and glycerin soaked into some kind of a cardboard or fiberboard strip. And this is research has told us that these different extended release oxalic acid products are good at slowing down mite population growth, preventing that exponential growth that we saw in the graph. They are not ideal for knocking down high mite levels. So if your mite level is already starting to get out of control, this might not be the product to reach for. But if you think your mites are under control, this might help to get you through, most or maybe even all of your main honey production season without having to have, additional treatments put into the hive. So these are safe to use with supers in place with a little caveat that you want to separate them from your honey supers if possible. And they're not going to penetrate the brood caps. So you need to leave these in the hives long enough that the bees will keep bumping into them and getting oxalic acid on their bodies, which then the mites are exposed to. And then the last oxalic acid product I'll mention is a brand new product called Apibioxyl RTU, which is one that has just been released in the US. State approvals are just now nearly done. I think there's a couple more states that have yet to approve this, but we're hopeful that they will be done swiftly. And this is another oxalic acid product which is dribbled onto the hive. So this is mixed with not sugar syrup, which is what people have been mixing oxalic with and dribbling on hives for quite a long time, but instead a mixture of glycerin and water and other food-safe inert ingredients that bees aren't terribly tempted to eat. So unlike mixing your medicine with sugar, dribbling it on the bees, and then watching as your bee colony devours it, you're mixing it with these non-sugar ingredients, and then it is allowed to remain sort of moving around in the hive without the bees consuming it all. The concentration of this stuff, of oxalic acid, is 6.2% as opposed to 3.2% in the stuff that you're allowed to mix at home with some sugar syrup. And there's also no maximum dose per hive. It's just 5 milliliters dribbled in between every frame of your bees. And so this has a lot of advantages over the older sort of classic oxalic acid sugar syrup dribble. And it also avoids the mixing and the mess and the math that is required to put it all together. So I'm really excited about this. This is what I'm using on my own bees this spring to try to take whatever mite levels they've got and knock them down, just a little bit lower going into the summer. And then the last product is amatraz-based, the Apivar 2.0 strips. And so these are not safe to use with honey supers in place. They're a strip that sits in the hive for a long period of time and kills the Varroa mites inside whenever the bees bump into them and spread this chemical around. But the treatment course when your colony has brood, which hopefully they do in the spring, is 70 days long. And so you need to be able to do your math and figure out when you need to put your honey supers on your hive to prevent the bees from getting all plugged up with incoming nectar, and then go back and make sure that you've put these strips in time that you can take them out before the supers go on. So as I said, for a lot of us, we may have passed that window this year, but if you anticipate it, you can plan for it the following year. So that's mite treatment, and it's not probably going to be make or break for your colony. There are other chances to get your mites under control, but as I said, these are probably going to be the most valuable individual mites that you'll kill because you're killing all of their progeny going forward. So the other thing we might have to do is feed our colonies when the weather is cold. And there's a major difference that happens between whether the weather is above or below about 55 degrees Fahrenheit. If you give your bees liquid food, sugar syrup, in cold weather, they are not going to be able to hold in that excess moisture in their bowels, and that's going to cause dysentery. It's one of those causes of bees having bathroom accidents. It also just might not be accepted. The bees might not be interested in a feeder full of sugar syrup because they know that they can't handle that extra moisture. And of course, if it does drip on your bees, if you have some feeder malfunction, there is a risk that it could chill them when the weather is quite cold. So there are a lot of other solid feed options that beekeepers turn to in the winter and in the spring to help their colonies get through until the flowers start producing enough nectar or the weather is right to provide sugar syrup. So very quickly, I'll just talk through some of these solid feed options that you may need to rely on or may already be relying on in your bees. So this is emergency feed that we give to the bees that have run out of honey. And one of the most valuable tools in this process is a feeding shim, this little extra spacer that you can put into your hive so that you've just got that extra space within the shim's boundaries to pile up some kind of sugar feed. So one strategy is feeding bees fondant. Fondant is just sugar mixed with a little bit of water to make a sort of malleable paste. And so we can feed that to our bees. This is the prepackaged Hive Alive infused fondant inside a plastic wrapper, and you can just cut a little hole in that wrapper and set it right on top of the bees. Folks will also go to the store and buy a whole big slab of baker's fondant and then cut that down to size and put that onto their hives as well. Some folks use candy boards. The definition for what a candy board is often varies from person to person who is using them. But essentially, a candy board is something like a shim, some structure, and then some kind of fondant or other sugar, semi-solid sugar or solid sugar that you've mixed into it so that your bees are able to go up and lick at that sugar, and that shim is going to provide the support for it. One really handy strategy that we like quite a lot here at Betterbee is making sugar bricks. And so a sugar brick, the recipe is pretty simple. For every pound of white sugar, you add 1 tablespoon of water, and then you mix it up. This is some screenshots from a YouTube video on Betterbee's channel where our head beekeeper, Anne Fry, is making some sugar bricks for our bees. And so you mix it up, in her case, with a paint mixing attachment on a drill until it feels like sandcastle sand. And then we press it down inside some frames. These are actually shims that we've pulled out of the storage shed, and then make them into these little rectangular bricks, which can then be put directly onto the hive. So this is just a little animation showing that even when the bricks break apart a little, it's quite easy to haul them into and out of the apiary and to set them up on top of the hives. This is a little bit more manageable than what some folks use, which is called the mountain camp method. Mountain camp method is essentially taking a sheet of newspaper or tissue paper and then dumping a whole bunch of granulated sugar on top of it and trusting that the bees and the moisture that they're breathing out, which will then cause that sugar to kind of crystallize onto itself, is gonna sort itself out, and the bees will be able to get good food out of it. So this is a strategy that some folks use with great success. We find that the sugar bricks or some of these other products are a little more straightforward to use. And then the last product is the winter patty. So this is a prepared fondant, but it's a fondant that contains some mixture of other things. Typically, it's going to have a little bit of added fat, a little bit of added protein, and then some vitamins, minerals, maybe some kind of an odorant that's going to attract the bees up to it and get them focused on it and licking it. And this is going to provide the same thing that any of these other sugar products do. It gives the bees an opportunity to lick it and get themselves some extra sugar that they can't get from either a syrup feeder because it's too cold to give it to them, or from their stored honey because they don't have enough of that. And so this is the simple application of these winter patties. You can add one or multiple patties to the top of a hive inside of a shim. So all of this solid feed that you may need to put onto your colony in the late spring is the emergency heating fuel that your colony needs to keep themselves warm. If we have a late season blizzard that blows in and you go out and open up your hives in the middle of it, there's a possibility that they will die. But if your bees have run out of honey and that's the only day that you can go add a sugar brick to them, I recommend that you do it. Because if they run out of sugar, they absolutely will die. And so it's our obligation to understand that even if it's a little risky to go manipulate a hive, open them up, and put these bricks in, it's necessary to provide them so that the colony doesn't starve. When we're making these, whether we're mixing up sugar syrup or making any of these, emergency feeds, you need to remember to only use highly refined granulated sugar. That is going to give you the best results. Doesn't matter if it comes from beets or if it comes from sugarcane. They're sucrose crystals, and they have refined the heck out of them so much that there's basically nothing in that bag except sucrose. However, if you use other sugar sources, folks will sometimes try to be more natural and help their bees in a more natural way by giving them sugar, maple syrup, or this turbinado cane sugar in the raw. It sort of looks like the whole wheat flour of sugar, right? So what could be wrong with that? Well, unfortunately, a lot. The extra molasses and extra minerals and extra fibrous materials in those less processed sugars, those can contribute to that high ash content that causes dysentery inside of a colony when the bees aren't able to go take a cleansing flight every day. And so it's important to remember that refined, highly refined sugar that's not very good for our bodies is actually pretty darn good for our bees. Now, at some point, we're going to switch over to feeding our bees liquid, especially if we find that we need them to build comb, or if we find that they've really significantly run out of it, and the flowers in our area are not picking up the slack and providing our bees the food that they want. So if the weather gets above 55 degrees, if not every moment of every day, at least regularly and consistently above 55 degrees every day or so, then we could start to give our bees thin sugar syrup or light syrup, 1-to-1 syrup, 1 part sugar to 1 part water. In cold weather, you want to make sure that feeder is very close to the bee cluster itself. So if the bees are inside of a cluster in the cold weather, or the cold part of the day, they expand and they can move around and get access to that feeder, and then they contract again into a cluster. You do not want to give them a feeder that's 3 boxes away from them. You want to make sure that whatever access they have to that sugar syrup is quite close to the bees themselves, even when they formed that cluster. So the best results are going to come from a hive top feeder, a pail or a bucket feeder on top of a hive, or a frame feeder, a division board feeder that fits inside of the hive. So over here in the upper left, we've got a hive top feeder that has a big reservoir above the bees that they can crawl up to. You wouldn't want to have extra boxes in between the cluster and the bottom of that feeder, though. Below that, we've got a frame feeder, this little black sort of trough that fits in place of a frame or two and allows the bees to crawl right down into it to get syrup. And then on the right, we have a pail feeder and another style of a hive top feeder, which is basically just a slightly more high-tech version of that plastic bucket. Personally, I think that blue Be Smart feeder is my favorite because the lid screws on. I don't have to mess with the seal at the top of that bucket. I can just fill that up with a gallon of sugar syrup. I can flip it over and put it on top of my bees. And when it's empty, I can take it off, unscrew the lid, fill it up again, and then put it back into the hive. So those are the different kinds of feeders that we aspire to use as the spring evolves, but we're not quite there yet. Now, many of us probably went outside, at least if you live around where I do, in the last couple of days and thought, hey, spring is here. And then as we go outside today, we might think, ugh, maybe I was mistaken. We had that false spring, and this is very common. It's typical that spring arrives and then vanishes, and then arrives again and then vanishes again. And at some point, it sticks. But it's hard to know whether or not that has happened until it's happened. So I want to just tell you a little story by showing you some hive photos about the consequences of this sort of will it or won't it relationship that spring has with us. So these are two photos that I took of the same hive with two different cameras. One of them is a regular camera, and the other one is a thermal imaging camera. And I took this photo to illustrate exactly what these bee clusters look like in winter when they condense themselves down and start generating heat. That small area that the bees are occupying, that red and white area where they're generating all of that heat and clustering around each other, is quite warm. But the area outside of that is quite cold, right? This is in weather of about 45 degrees Fahrenheit, if not colder than that outside. And I want you to notice that the area near the bottom board, the area at the bottom of this hive, or up near the top of this hive, is the same as the ambient temperature outside. So the bees are heating their cluster, they're not heating the entire hive. This is another pair of photos. This is two different colonies. But what is striking about these colonies is that these colonies were the exact same strength. They were just taken on different days that had very different ambient temperatures. So in the spring, when you're going and looking at your colonies, you may find one that looks like the bees on the left. It may find bees that look like the ones on the right, but you need to understand the consequences of the ambient temperature on whether those bees are out and about, moving around, cleaning and growing, or hunkered down, clustered up together and trying to stay warm. Now, what that means is that unfortunately, our bees are going to spend part of the spring, remember, which is all about growth, making a nice big brood nest and expanding it and growing it and trying to make as much brood as they possibly can. That's great in warm weather. But when cold weather comes, what are those bees going to do? Well, they're going to condense back down into a cluster to keep themselves and the queen warm. They're going to put that cluster around as much of the brood as they can, but there's typically going to be some brood on the edges. If your colony was optimistic, if they were a little overambitious and started building more brood than they could keep warm when the weather turned, there's a possibility that you'll get large sections of chilled brood as this weather yo-yos up and down. So this is actually one of the places where an insulated hive can really shine. And it's one of the reasons that I don't recommend taking the hive insulation off of your hives when you do that early brief inspection early in the spring, because now might be actually the time when the bees are most appreciative of that hive wrap or that bee cozy that you might have put over the outside of the hive. This is also a really good opportunity to mention that some people just use fully insulated beehives. So over here on the right, this is the brand new sort of latest and greatest polystyrene hive that Betterbee is carrying, which is the Lyson Rapid Hive. And this rapid hive is made of polystyrene, a high density, insulative foam, and it's got a plastic bottom board and then otherwise polystyrene components, and it provides all of that great insulation that these bees need. So as the weather goes up and down and up and down and up and down in the spring, the bees inside are able to keep relatively warm. They're not losing as much heat to the outside, and so they can keep more of their brood from getting chilled, even if we do get a cold snap. The other consequence of this up and down temperature problem in spring is that the flowers that our bees depend upon can also suffer pretty dramatically. So you need to monitor which flowers and which trees are blooming, and you can't just try to get a rough sense of what happens in one year and assume that that's always going to happen each year. You have to pay close attention each and every year to that maple tree on the corner of your property, or that patch of daffodils that you walk past to get your morning coffee every day, because that's going to give you a sense of whether or not the bees are getting ample flowers, or if the flowers, at least if some of these species, have been tricked, and if the bees might now be suffering because suddenly some source of pollen or nectar isn't available. And so, we've got a bunch of resources. There's this article that we wrote for the Betterbee newsletter, which is still available on our website, Seasonal Flowers of Early Spring. I think you can just Google, Betterbee spring flowers, and this will probably come up. But it gives just a little description of some of those most important flowers that our bees are encountering in the spring. So there's something beautiful like a crocus flower, which actually doesn't contribute all that much to the bees, but which I really like seeing. But as you go down, things like snowdrops and dandelions that start to emerge as the spring wears on are extraordinarily important. And that's in addition to the many flowering trees that provide a lot of the most important new nutrients that our bees are going to be collecting. So as these colonies grow, hopefully they're going to grow because that's what spring is all about. They are probably going to very quickly start running down towards this path of swarming. And the reason that this happens, and it happens even to the best of beekeepers, is pretty straightforward. In nature, bees grow their population after every winter. In nature, bees swarm after their population has reached a maximal size, typically in the spring and the summer, so that they can make daughter colonies. So you grow and grow and grow until you run out of room, and then you split, and then some of you stay behind, some of you go and found a new colony, and now we've got more colonies. The issue is our bees don't know that they don't live in nature anymore. And so they're still doing these basic, fundamental, instinctual reproductive things. People will often ask, when is the swarm season? When do I need to worry about swarming? And my quick and lazy answer is simply spring through fall, right? Any time other than winter is a time when your bees might swarm. Around here, the traditional wisdom is encapsulated in this poem. A swarm of bees in May is worth a load of hay. A swarm of bees in June is worth a silver spoon. A swarm of bees in July isn't worth a fly. The idea being that typically bees that we are able to catch in May and June, which is when a lot of the swarms will happen, we can grow up into a functional colony and then get through the following winter. But if the bees swarm in July, they're not going to be terribly valuable to us. They're not going to do very well. That's not exclusively true, right? So I might have put that in green, sort of coding that for the Greenwich, New York area. But over here on the right is a graph of swarms that were observed in the Washington, D.C. area. And what you can see is that their swarming season doesn't run May, June, and July. Instead, it runs sort of April, May, and June. Things are shifted earlier in other regions. And so we need to know when bees are actually swarming where we are, and we need to make sure that we are getting ahead of that swarming instinct, removing those swarming cues well before swarming season begins. So what is it that actually triggers that swarming process? Well, a hive that has come through the winter and is now regrowing is perfectly primed to swarm. Things that are likely to trigger it are if there is no remaining nectar storage available for those bees to use. If their brood nest gets all plugged up with nectar, that's not quite the same. So if there's no nectar storage up in the honeycombs, that's one thing. But if there's so little storage that their brood nest, the places where the queen is supposed to lay eggs, are also getting plugged up with nectar, that can really contribute to this instinct. And if there's not enough queen pheromones circulating inside of the hive. And so what happens there is that as the bee population grows, there's only one queen making these pheromone chemicals. And so the relative concentration per bee goes down. The bees can sense that. It gives them a sense of how big the colony is. Queen pheromones suppress the production of new queens. But if the queen is getting older and getting weaker, or simply if there's a ton of bees who are drowning out all of that queen signal, then the low levels of queen pheromone can trigger the production of queen cups, the beginning of those queen cells that are going to be part of the swarming process. So how do we fight this swarming as we manage our bees in the spring to prevent them from swarming in late spring or early summer? Well, we don't want to let the colony become crowded and full of nectar. So we want to make sure we're adding extra combs to make sure that that brood nest does not feel too constricted. We could limit colony growth, but obviously that's not what we want to do. We want our colonies to grow in spring just like they do. We just don't want the end point of that growth to be a swarm. We want it to be a whole bunch of honey that we harvest later in the year. And so one thing that many beekeepers do is basically try to get ahead of that swarming instinct, admit that there's going to be a division, but have it happen on our own terms. And so we split the colonies. What you don't want to do is simply panic and cut all of the queen cells out of your hive, though, because that's rarely going to achieve what you want. You'll rarely get all of the queen cells, and so they'll still swarm, and it's not going to be proactive. It's just going to be reactive. So that idea there of splitting your bees, or sort of a controlled swarming, is a helpful way to avoid fighting against the most fundamental urge that our bees have of spreading their genes and reproducing. It also is a way for you to increase colony numbers. If you had 5 colonies going into the winter, and now you only have 2 coming out again, if you split those 2, you might be able to get yourself back up to 4 or maybe even 5 colonies going into the following winter. In order to fuel those splits, beekeepers will often try to stimulate extra brood production. If I know that I'm going to split one of my colonies, I might get myself a protein patty or a protein supplement and give that to my bees to try to make them manufacture more bees sooner than they might otherwise be inclined to do, so that I've got lots and lots of bees to work with. And so one way you can do that is 4 to 6 weeks before your honey flow starts. Our honey flow around here typically is going to be around May 1st. So, 4 to 6 weeks before that would be a reasonable time to start boosting colony productivity, and before any natural pollen is coming in, giving those bees lots and lots of extra protein. That can help to increase the number of bees. You might also just try to time it relative to your splits. If you know you're going to make your splits in mid-May, then 4 to 6 weeks before that, you can give them some of this food. And the reason for this 4 to 6 weeks, the 6 weeks in particular, is because it takes 21 days for a colony to turn an egg into a new worker. And so if we give our bees 6 weeks of extra fueled growth, it's going to give us 2 complete brood cycles worth of new bees that the colony has manufactured. But there's a problem here. The more brood you've got, the more bees you've got. The more bees you've got, and the more brood you've got, the more honey they need to consume in the late spring in order to keep everybody warm and healthy. So if your colony is already sort of limited for the amount of food they've got, and you can't put a syrup feeder on, this can actually get the colony in trouble. They'll overgrow themselves. There's also, of course, a lot more potential for swarming. So the temptation to feed your bees a protein patty or a pollen patty is probably not appropriate for folks that don't plan to split their bees, unless the bees are in a particular circumstance that requires a little bit of babying or a little bit of help. So, for example, I've got an observation hive of bees here that I keep here every winter, and this colony is, I would say, probably not the strongest I've ever seen. The cluster is maybe about the size of maybe both of my hands put together. That colony is getting a little bit of protein patty to help to supplement their growth, but that's because I know that there's not much risk that they're going to swarm from a colony that size. So those protein supplements are variable. You can get global patties, which have some real pollen inside of them. Mega Bee is a powder, which doesn't contain pollen, but it's engineered to be as close to bee pollen as possible. And you also could simply collect pollen in a pollen trap in the summer, and then pop that into a freezer and rub it inside of some of your empty frames and put it next to your bees the following spring. And so this is something that some folks do. If you're proactive about getting the pollen earlier, you can take pollen from a big colony that can spare it, and then give that to as a supplement to a colony that might need a little bit of assistance the following year. It is really important to maintain the distinction between a winter patty and a pollen patty. So they're both orange blobs of goo wrapped in wax paper, and it's easy to get a little bit confused. But these are very different things. The winter patty is mostly sugar. It's got a little bit of Honey Be Healthy, which is a feeding stimulant, and a little bit of protein, a little bit of fat. It's basically just a sugar for supplemental emergency winter food. The pollen patties also contain sugar, but the vast majority of what these bees are there to get is the protein. 15% of that patty is pollen. There's more protein than 15%, though. It's just that it doesn't all come from bee pollen. It might come from corn and soy and things like that. And so our bees are going to be licking these patties, but for very different reasons. And a beekeeper might need to put a winter patty on a hive in the winter if their colony runs out of food, but they may not need to give that supplemental pollen if your bees already have a bunch of pollen stored inside of their own combs from the previous fall. So if we decide to split our bees, there's a few different ways that you can do it. You can do what's called a walk-away split, where you simply walk up to a colony living in two boxes. You put one box over on a different bottom board and set up the other one the way it was, and then you walk away. That's it. One of those colonies gets the queen, the other one doesn't. The one that doesn't is going to have to make a new queen, and there you're off to the races, and you've got two colonies. Obviously, you can't do this until you know that there are drones flying around to mate with that new queen. And in some areas, it can take quite a while for the weather to be warm enough for the bees to start making new drones. So a slightly easy or pretty easy way to make a split is to simply wait until one of your colonies is ready to swarm, and then take the frames that have those swarm cells and move those off into your split. So let the bees get the process started, remove all of the swarm cells from the colony that you don't want to swarm, but then give it to what is essentially a walk-away split with a head start. You can also take a caged queen that has been bred by another queen breeder, and you can make a split and pop that queen right inside of it. This works as long as your bees accept that new queen, but it's not without costs. You have to pay for those queens, and if something goes wrong, you might need to buy a replacement queen to fill in the gaps. The advantage of this, though, is that if I'm up here in New York, it's going to be quite a while before I've got any queens and drones that are able to mate with each other. But down in Georgia or Florida or California, there are probably a lot of bees that are already either ready to mate or nearly ready to mate right now. That means that I can buy somebody else's queen produced in warmer weather and introduce it to my bees before those bees would themselves be able to produce a mated queen. And then obviously, if you get really excited, you can get into queen breeding. Betterbee offers a queen rearing course, which you're more than welcome to sign up for and drive up and visit with us this coming June. But that is probably not the easiest way to prevent swarming, but it is sure a fun way to do it. So when we're making those splits, you do need to be mindful of the foragers that you're working with. So if you move your hive simply within the apiary, you're going to wind up with a lot of foragers going back to the original hive location that they've always called home. And so whichever box moves away from that home location is going to get depleted pretty quickly. If you are able to move those colonies outside of the apiary, you're going to wind up with more success as long as you can go somewhere in the neighborhood of 3+ miles away from the apiary. So you might need to manipulate these colonies a little bit, make sure that the part of the split that moves away has more bees because you figure that you're going to lose them. And you can also do some things to trick bees into reorienting to the entrance to their box. So take a leafy branch or 5, cut them down, put them right in front of the entrance, and when the bees crawl out the next morning, they're going to look around and say, hey, the tree we live in seems to have fallen down. So let's relearn what our entrance looks like. And you can kind of trigger that instinct and get more of those bees to remain in that box, even though the box they're used to living in is just on the other side of the apiary. But what I want to emphasize is that natural protein is already out there, or it soon will be, or it already has been. What I mean by that is, your bees, if you're not planning to split them, might not need that supplemental protein because things like a maple tree here are about to bloom, and there's an awful lot of pollen on them. Your bees also probably have already been raising some brood and growing a little bit before any flowers have bloomed. And that's because they stored pollen last fall and then they made use of it this spring. So these natural pollen sources are often, for many beekeepers and many bees, plenty for them to do all of the growing that they need to do. And those supplements are not something that should be treated as sort of a matter-of-fact thing to give to our bees every spring if we aren't trying to manufacture new bees for a specific reason. If your bees swarm every year and you give them a protein patty every year and you don't split them every year, it's possible that you are unnecessarily triggering your own problem. So when we feed our bees in the spring, in summary, we're going to give them solid sugar if the bees have got no liquid sugar to eat. If they don't have any honey or syrup that they stored last fall in their frames, then we need to give them some solid sugar to lick. And they're going to need to get that continuously until nature takes over and they've got flower nectar coming in. If you've got pollen patties that you want to give to your bees, that makes sense if you are trying to split your colonies or boost the growth of a colony, but you're going to need to feed them continuously until natural plant pollen starts coming in to replace it. The last thing you want to do is give your bees enough protein patty that they can start raising an extra 5 frames of brood, only to take it away or not give any new protein, and then have those bees have to cannibalize some of the brood to feed to the other brood. That's not a good situation for anybody. We'll feed our bees syrup as long as the weather starts getting above 55 degrees Fahrenheit, and we're going to use that to fuel the growth of the colony until a nectar flow begins, at which point, hopefully, we might be able to put supers on our bees and actually start making some honey. So that's the brief inspection. The thorough inspection in maybe April or May in our neck of the woods, this later inspection, and for some of you in areas further south, this might be more the period that you're now in with your own bees. Now is when we're going to start doing some more normal, recognizable beekeeping behaviors, going in, pulling out frames, looking at eggs, looking at some of the issues that might emerge and trying to correct them and helping our bees grow. So what do we do in this real inspection when we dive into those hives? Well, we want to make sure that each hive has adequate brood. And if we've got multiple hives and 2 of them are maybe a little too strong, we're worried they're going to swarm, and 1 of them is a little too weak, we might pull a frame of capped brood out of the stronger hives, shake the bees off of them, and then move that brood over into the weaker hive. That's going to help to pull off a little bit of the extra heat from the hives that are growing too fast for us and help the other colony catch up. We need to make sure that there's no evidence of brood disease. Maybe that colony is weak because they've got something like chalk brood. If they do, we might need to requeen the colony, or maybe we just need to feed them and wait, because chalk brood, a fungal disease, often resolves itself. If that colony has American foul brood, however, we might find ourselves, calling the bee inspector and arranging to euthanize and burn that colony. So look for these signs as soon as possible. You want to catch these things as soon as you can if they require intervention. If the hives have been insulated up to this point with some kind of a wrap, now is probably the point to remove it. They're going to start getting annoying during your inspections afterwards. If you have an insulated polystyrene hive, obviously you don't need to worry about that. And you also need to get ready to start adding supers to your colonies. And here I've got this labeled the week of the dandelion bloom. And I want you to notice that that isn't in green, because conveniently, no matter where you live, I can pretty well guarantee that you've got dandelions that bloom in the spring. And when that big dandelion bloom happens, is going to be synchronized with typically about the time that you need to be getting supers onto your hives, if not a little bit before. And you might also restructure the hive a little bit, reorganize the hive, move some frames or move some boxes. So I'll just talk through a few key points for these major spring inspections that you either have to look forward to, or maybe a few of you, if you're in Florida, have already done. So you look at your brood, you try to evaluate the quantity and the quality of that brood. This looks like a good brood pattern. I'm pretty happy with this. If I saw something like this, drone brood, and especially scattered drone brood, I might start to get worried. I might say, this seems like I may have a queen problem, and I need to start calling around to see if I can buy a replacement queen for this hive. If I see any signs of brood disease, typically in the spring, they're going to be, as I said, either this fungal disease, chalk brood, which more often than not is resolved as long as the colony doesn't completely collapse, from lack of brood. This can be resolved when the weather warms up, things get a little bit drier, and the bees have lots of nectar coming in to help feed their brood. But if you see these chalk brood mummies, these bees that have been killed by fungus on the landing board, you can just sweep them away, but keep monitoring that situation because it could get into something worse. On the right, we have American foul brood. This is the telltale scales at the bottom of cells that have been infected with American foul brood. These are basically bee pupae that have liquefied and then sort of glued themselves down to the bottoms of these cells, which have subsequently been opened by the bees. And so in this case, if you see any sign of brood disease like that, call your local bee inspector, confirm the American foul brood diagnosis, and then prepare to euthanize the bees and destroy that equipment. When you do your brood inspection, you might have some action that is called for by you. So if your queen is failing, or if your queen is weak, if your queen simply can't keep up with the other queens that you've got in the apiary, then you might need to replace her. For whatever reason, she's starting to flag, and you don't want to sacrifice all of this great spring growth because you've got a dud of a queen in your hive. Maybe your colony is sick, right? They might need some treatment, or they might need to be euthanized. So you need to catch these signs early. And as I said, if your colonies are of unequal strength, you can do essentially a brood transplant from one colony to another. It's important not to take a bunch of open brood from a strong colony and give it to a weak one, because that weak colony now has to provide all of the food that that open brood requires. If you have capped brood in a strong colony and shake the bees off of it, when you move that over, all the receiving colony has to do is keep it warm. And now those new healthy bees are going to crawl out and start contributing to the workforce. I had said that you might need to do some rearranging of your hives. And one of the most important things that many beekeepers do is reverse their brood boxes. So this is a photo of an all medium hive setup. So it's 3 medium boxes, but the principle is the same even if you just had 2 deep boxes. So what has happened here is, as typically happens, the bees started the winter in their lowest box and they ate through their honey and worked upwards. As they got towards the end of winter and into the spring, now the cluster of bees is up near the top of the box, but the bottom box is essentially empty. When we reverse our boxes, we're going to take those empty bottom boxes down below and move them up above so that the bees now have the opportunity to grow upwards into them, because bees would rather grow upwards than downwards. However, you need to be careful when you're doing this. You do not want to split the brood nest. So in this case, with these 3 boxes, if I decided that I was going to take just one of those boxes, maybe the yellow one off the top, and put it down on the bottom, I would now have created 2 separate brood areas. And on a chilly day in the following week, my bees might not be able to keep both of those areas of brood nice and warm. And so you need to have some sense of what's going on inside of the hive before you decide that it's in your place to start swapping things around. You also don't want to do this too early. So typically we would recommend doing your box reversal, or at least your first reversal, around the time that your dandelion bloom is really hitting its stride. So I mentioned that there might be more than one reversal here. The first reversal might happen with the dandelions. If you then go out and find that for whatever reason, once again, your top box, brood box is full, but your bottom brood box is relatively neglected, you can swap things around again. But you shouldn't be doing this every week throughout the season. This is something that you do once, maybe do twice, just to really get those bees thoroughly occupying both of those brood boxes, and then you carry on for the rest of the season. Another extremely important thing to do, and which many beekeepers wind up doing too late, and that's why we talk about it in our spring lecture instead of our summer lecture, is adding supers to your hives. So at the start of your honey flow, you need to have your supers. Ideally, before the start of your honey flow, you need to add supers to your hives. In Greenwich, we expect our maple trees to peak around the last week or so of April, and those dandelions are going to peak around the 1st of May. Now, the dandelions might have started in mid-April, and we'll see a few blooms here and there, but we're going to see that really, really robust, dramatic dandelion bloom in the spring around May 1st, or at least in some years we do. So paying attention to the seasons, you need to make sure that you're adding supers to your hives. And as I said, it might be around peak dandelion time that you're doing that box reversal. Adding supers in our area typically needs to happen at least 2 weeks prior to that. So before this big maple peak happens, we need to get these supers on so that the bees have somewhere to put all that maple nectar. And the other thing that beekeepers sometimes get all worked up about is there's no reason that you can't add 2 or more supers to a fully sized colony if you think that they're going to forage for enough nectar that they're going to need that extra space. You don't have to add 1 box at a time. And this is because when your honey flows come and you need to learn what they are and be prepared for them, that nectar is going to come into the hive and it will often be somewhere in the neighborhood of 60 to 80% water. The bees are going to work over the course of a few weeks and they're going to evaporate extra water out of it so that they can make honey. Honey is going to be less than 20% water. Well, what that means is that as all of that water evaporates, that the amount of nectar they brought in is going to shrink and shrink and shrink and shrink. What that also means is that if you know that a particular honey flow on a strong colony is able to produce an entire super full of honey for you, You can't just give them one super because they're going to need more space to bring in all of that material and ripen it down, and then they will condense it themselves into that single super you're able to harvest. So if I have a colony that in a year can make 3 supers worth of honey, I can't give them 3 supers worth of space. I might have to give them 4 or 5 supers worth of space if my honey flows are coming in so fast that they need a lot of extra room to store that nectar. This is also a critical part of good swarm control in your colonies. If you give them their supers early and if you give them plenty of super space, it means that they're never going to have that temptation to cram some nectar down in the brood nest, to make the colony become honey-bound, and to stop the queen from being able to lay eggs. When that happens is a very, very strong and potent trigger of that swarming instinct. So giving them the extra space early in the season and then keeping extra space on the colony at all times is a great way to fight against that swarming. And then we've talked about different opportunities to feed our bees in spring and the importance of feeding to help to fuel growth. But a really important question is, when do we stop feeding our bees? Well, there's 2 questions that you need to be able to answer. One of them is, do you want to have syrup in your supers? Typically, the answer is no. Certainly not if I'm selling that honey, because now I'm defrauding my customers by claiming I've got honey when really it's just sugar syrup that the bees packed into some cells. However, are you asking your bees to make wax and to build comb? Because that process is so costly, it can make sense to continue to feed your bees even though there's natural nectar coming in from flowers. So when I put a super on my colonies that doesn't have any drawn comb, I don't have any hesitation to keep feeding those bees even if some natural nectar is coming in, because I would like them to build out all of the wax in that super instead of just turning all of the incoming nectar into wax. Now, what that means is that if I extract anything out of that super, obviously I can't claim that it's honey. I can eat it, my family can eat it, I can give it to my mother-in-law as a Christmas present, but I can't call it honey because I know that there's probably some sugar syrup mixed up into it. But it is still going to help me get that comb built so that the following season I might have 2, 3, 4 drawn supers of comb that I can slap onto my bees during a honey flow. And at that point, I would absolutely make sure the feeder is gone so there's no risk of contamination. So you need to make that decision about when to pull the feeder off, but understand that if purity of your honey matters, you need to get it off before the supers go on. If that's not actually that important for your beekeeping, there may be a circumstance where it makes sense to be giving that little extra trickle of food while the bees are also bringing in some natural nectar. So what have we learned in this big, long, sort of rambling lecture I've given you? Well, spring requires some important action from your beekeeper, but that action happens as the weather allows. The weather is going to set the schedule, and the bees will set the schedule. I can't sit here and tell you that on this date you need to go out into your hives and check them, because that date might be 20 degrees Fahrenheit or it might be 70 degrees Fahrenheit. You need to wait for the right opportunity to go out and do those initial cursory inspections, and then also later on to do those more thorough inspections. You also need to get yourself ready to do these tasks before you have the couple of hours that are actually available to go and do it. If it's only going to be above 65 degrees Fahrenheit from 2 p.m. to 5 p.m., then you better make sure all of the equipment you need is ready to go before 2 p.m. Your bees are still going to spend some time on their own, just like winter, that impotent time when we as beekeepers aren't actually able to go in and do anything. But spring gives us these little moments where we can step in, intervene, evaluate, and maybe offer something to the bees before we have to step back again. And as the spring wears on, eventually we're going to be able to spend more and more and more time with our bees. If we screw up in spring, if we fail to act, if we don't do something, or if we do something wrong, it can be more dangerous than errors that happen later. If I crush my queen during a spring inspection, I may not be able to get a new queen because nobody might have them. If I do that in June, I'll feel like a real moron, but I know I can buy a queen from somebody. And we also can't necessarily go in and fix something. If we do something wrong on Monday, we can't go in on Tuesday to correct it because Tuesday might be snowing again. So you've got to make sure that you are diligent and paying attention to what your bees need and listening to what it is that they're able to tell you on the days that you're able to work with them as the spring starts to unfold. If you've had fun listening to this, if this has been interesting to you, I will point out that Betterbee offers a whole bunch of different classes. I teach many of them. If you don't like me, but you like learning, our head beekeeper, Anne Fry, also teaches a number of our courses. And so these are available online or in person. So if you'd like to take any of them, by all means, feel free to go sign up for one. We also have a whole bunch of free content on our YouTube channel, and it's very helpful. If you like it, please subscribe to the channel. It helps us to continue to get access to more YouTube tools and to produce more content for you. So by all means, if you've enjoyed any of this, I believe we're going to be putting this lecture up on the YouTube channel as well. If you want to go rewatch it, or if you want to share it with a friend or somebody in your local bee club. And so we're trying to produce as much content as we can to make you be better beekeepers. That's our philosophy. It's why the company pays to have a scientist here. I'm not here to sell you anything. I'm just here to help keep you and your bees healthy, happy, and thriving. And then, they figure you'll keep buying hive equipment if your bees keep multiplying. So with that, we've come to the end of our prepared remarks. I hope you enjoyed them. I hope you found it interesting. I hope everybody learned something. And so that brings us to our Q&A session. If you don't have time to ask a question, or if you've got to run, by all means, feel free to send an email to us at support@betterbee.com. We're always happy to get questions about products, but also just about beekeeping or anything that I might have mentioned today. And I will point out and thank our head beekeeper, Anne Fry, for her contribution, and the few other Betterbee employees that contributed a number of photos that I used throughout this presentation. So thank you to Anne and her constant and diligent photography while she's also out there, hauling supers around and keeping our bees alive. So with that, I will stop sharing my screen. Thank you very much for your attention. And if anybody needs to duck out, you can do so at any time. But I am very happy to answer questions for as long as we've got time to do it. All right. Oh, good. There's still people here. There's always that concern when you're just speaking into the void. Okay, so as we said before, for those that missed it, any questions you've got, just click on that little Q&A button, type your question in there, and then Elizabeth, I think, has been answering a few of them as we've gone, but I'm just going to run down through the questions as they've come in, and I'm going to answer them to the best of my ability. I'll give you an answer, no guarantees whether it will be right or wrong, though. So Heather says, can you talk temps, when to transition to sugar syrup over sugar bricks? Yeah, the primary cutoff there, Heather, is that 55 Fahrenheit temperature. And it's not that the weather needs to be consistently above 55 degrees Fahrenheit all of the time. It's that these bees need to be able to process that extra moisture and to purge it from their guts if they've started to consume that syrup. And so probably every day or two, you need to have at least a 1 hour window that is above 55 degrees Fahrenheit. That's going to allow bees to at least interact with that sugar syrup and get value from it. The warmer it is and the longer a period during the day that it is warm, the more likely you are to see, good outcomes from those bees. And it's just that they need to have warm temperature to process the syrup, to consume the syrup, and also not to have bathroom accidents from having eaten some of that high moisture syrup. Scott has asked, before I forget, could bees have been killed over winter by mites? Yes. How do you test for mites in a dead hive? I've already mentioned that, people think I'm crazy when I suggest this. Even bee scientists tell me I'm crazy, but it works. If you've got dead bees in your hive, do an alcohol wash on them and they will reveal something. If you've got 0 mites on all of those dead bees, it probably wasn't a mite problem. If you've got tons of mites on those dead bees, it could very well have been that the mites killed them. And if mites are the cause of death in your colony, thankfully, there's really nothing that you need to do to get that colony ready for the following season's, new package, new swarm, or new split. As I said, high levels of mites can lead to high levels of viruses. High levels of viruses can sometimes be detected in stored pollen or stored honey, but I wouldn't throw away honey or pollen just because scientists are able to find some of those viruses. It's unlikely that that's going to kill a good, strong colony that you put into it. Can a moldy frame be cleaned and reused? Yes, it absolutely can, and you do not need to be the cleaner. Bees are very diligent, and bees recognize what I've been saying all evening. Comb is valuable. It costs a lot to make, and so they will put the effort into cleaning those cleaning up those moldy combs, because they would much rather sit there and lick and chew all of that mold away than have to go rebuild all of that wax. Should we freeze combs with diseases to kill the bacteria or viruses? So typically, if your colony died in the winter, those combs have already been frozen. Many of these diseases are not susceptible to freezing. The freezing isn't going to be enough to kill them off. Sometimes freezing, and particularly freeze-thaw cycles, can lead to some reduction in the number of viable spores or infectious agents. But in general, no. The sorts of things that are going to survive a colony that has been killed in the winter, freezing is not going to protect them from, unfortunately. Does allowing a hive to naturally swarm, rear a queen, and go through a brood break due to that result in a reduction in the mite population? Yeah, that's a splendid question. So if my bees have swarmed and then produced a new queen, and if there's been this gap where the bees didn't have anyone laying eggs because they were waiting for the queen to mature, there's now going to be a brood break in the colony. That will reduce the Varroa mite population. The mites are running around looking for some brood to go reproduce in, and there simply isn't any brood to be found. And so those mites either die of old age or they make a little bit of a mistake. They go left when they should have gone right, and a bee grabs them and chews their legs off and throws them down on the ground. So yes, those brood breaks that you get from something like a walk-away split can reduce the number of mites inside of your hive, and that can be part of your overall mite management. Tim asks, where does the first Varroa mite come from? How do they get into the hive in the first place? That is an excellent question, Tim. So very frequently, I stand out here every spring and I hand out hundreds of bee packages and nukes to beekeepers. And folks will say, now, do you guarantee that there are no Varroa mites on these bees? There's no Varroa mite in this package or in this nuke. And I say, not only do I not guarantee that there are no mites, I guarantee that there's at least one mite in every one of these colonies. I guarantee that there's a mite in every package and nuke that any of you buys from any supplier. And it's not that there's anything wrong with those packages and nukes. It's simply that if you have honeybees, you have Varroa mites. It is almost impossible to kill every last one. And even if you do, chapters 2 and 3 of my dissertation were all about the ways that Varroa mites spread from an infested hive into a clean hive or an uninfested hive. And the short answer is the mites aren't doing anything so much as the bees are doing it. So if a bee has a mite on her body, gets a little bit confused and goes into the wrong hive, that's called drift. Mites can spread that way. But if a mite is inside of a colony and a robber bee comes in to steal some honey, that mite might be clever enough to say, hey, I'd like to go to, get a change of pace and a change of scenery and jump onto the robber and ride that robber home. So through those two mechanisms, these mites are extraordinarily good at getting from one hive into the next one. Does the reformulation of Apivar lessen the issue of Varroa resistance, or is that still an issue? So this new product, Apivar 2.0, that has just been released, is a reformulation of Apivar 1.0, and it contains the same active ingredient, this amitraz molecule. So the question is, does that reformulation reduce the likelihood of Varroa mites that are resistant, or the incidence or the problem of Varroa mites that are resistant to that active ingredient, which we know is an issue that has been spreading? To my knowledge, it is not going to solve that problem. I think that any reformulation is going to be an attempt to improve things, and so I do know that some of the quantities of amitraz or the release dynamics of that amitraz, the hope is that that's going to slightly increase its effectiveness, even if you've got some mites that might have partial resistance. But ultimately, no. If you have mites that are resistant to this molecule, putting that molecule in to kill them is not going to be your best strategy. So what we do know is that Apivar strips, this amitraz-based product, is a good way to kill your mites as long as you're rotating it with other miticides. Those other miticides are going to kill the mites that are not resistant to the active ingredient. So when you rotate that back into your mite management, then you're going to have fewer of those highly resistant mites dominating the overall population. So using it as one of the tools in your toolkit is a good strategy, but no, unfortunately, this reformulation doesn't completely solve that resistance problem. Another person has asked, will a new package of bees swarm in the first year? They absolutely can. A new package is less likely to swarm than an overwintered colony. A brand new queen is less likely to swarm in her first year than she is in her second year. But absolutely, 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 a colony can swarm in their first year if you're not careful and if you don't manage them and give them space and help them grow into the box that you've offered them, the hive that you've offered them, instead of having them feel cramped. Again, to reference this observation hive behind me, this is just 2 frames. And so if those bees were not able to find anywhere else to grow into, they can fill 2 frames pretty darn quickly in the spring, and they're going to swarm whether or not they're a new queen or an old queen. I have just heard a beep in my headphones suggesting that my microphone might cut out. So if that happens, I think Elizabeth is going to appear and tell me that I should switch around my microphone so I can keep talking. Hopefully we can get through to the end of this, though. Why no discussion of Varroa as a mite treatment? Yeah, so that's interesting. Now available in most states this spring, promising organic treatment. So yeah, so Varroa is this new product. It's whether or not it falls under an organic mite management depends a little bit upon your definition of the term. But what this is a genetic technology which is new. I haven't used it, and I don't want to recommend something that I haven't been able to use myself. But if I use it and love it this year, then maybe I will recommend it next spring. But it is a product which is essentially DNA molecules which have been engineered to have the mites absorb them, and then it makes the mites unable to lay eggs, or at least proper eggs. And so the mites wind up, it's sort of birth control for mites is the way that the manufacturer talks about it. It's a cool idea. The principles are sound, the biology is there. The issue, though, is it sort of like the extended release oxalic products, we feel reasonably confident it's going to help keep your mite levels low. It may not be that good at knocking down high mite levels. And so we need to figure that out. And also the way the product works, it's mixed into sugar syrup. So you can't feed it during a dearth or your bees will just eat it and it won't get exposed to the mites. But you also don't want to feed it during a honey flow because then it's going to get diluted with all the nectar, and so there won't be enough to kill all the mites. And so not every beekeeper in every region is necessarily going to have that perfect opportunity to use that product. So it's a real neat product. I'm excited about it, but it is, at this point, I don't have enough experience to definitively say I recommend this for spring mite management to all beekeepers. This continues to beep in my ear, so if you'll bear with me just one moment, I think I can relatively quickly, I got to get out of my slideshow so that I can change my speaker settings. I apologize for this, but a battery can only last so long, and this one's been able to handle quite a lot of my yakking. So the trick is just going to be finding my microphone settings. There we were. Nope, there we aren't. This is fun, watching David clicking around. There we are. Let's see if that works. So now Elizabeth will certainly tell me, oh, make sure this is working too. There we go. Elizabeth will definitely tell me if I'm talking, but nobody can hear me. But I'm going to work under the assumption that things are okay. So next question is, I have 6 frames of leftover honey. I have no plans to harvest that honey. With that said, is it okay to freeze those frames, thaw them in the spring, and place them in a new hive? Yes, so that's exactly what you want to do. If you have honey in frames that you aren't going to use, that neither bees are taking care of, nor you are going to harvest, you do not want to just leave it out, because it is very likely that those frames are going to crystallize. The honey inside will crystallize, which is a pain for everybody. If you freeze those frames, counterintuitively, cold honey crystallizes, frozen honey can't, because no water and sugar molecules are able to move around. So freeze the frames, store them that way for a year or a month or however long it takes, and then your bees are gonna fare very well whenever you give it to them. When you do a walk-away split, does it matter which hive gets the old queen at the old location or the new one? So yes, I cut some slides today because otherwise this talk would have been even longer. But I was tempted to talk about some of the nuances of walkaway splits. Unfortunately, I can't get into all of that. There are reasons that you might want to put the queen one way or the other. There's various sort of tweaks and modifications you can do where you go back a week into your split or 2 weeks into your split and you start transplanting brood from one hive to the other hive. But the short answer is we have a whole class all about swarming and splitting that I encourage you to take. Otherwise, yes, there's different schools of thought about whether the old queen should move or stay, and it all depends on what you're expecting each of those sides of the split to do. If you could only pick one product for Varroa mite treatment, which product would you select? I would refuse to give a single answer. And the reason is rotation between different active ingredients is the way that we avoid developing more mites that are resistant to one product. I will say that the products that I've mentioned here, things like the Apibioxyl RTU dribble, that's very easy, especially for a new beekeeper to understand and to use. Formic acid is very easy to use and is quite effective. There are a few products that are probably going to be higher on my list in my rotation, but I will rotate in and out some of these products every year to make sure that I'm not trying to select for mites that are entirely resistant to oxalic acid or entirely resistant to apivar strips. Should we feed sugar syrup if we put on a super that does not have drawn out comb? Look at that, I already answered the question. So if you are willing to get some sugar syrup incorporated into that comb while the bees are building it, and then you might have to harvest sugar syrup and suffer the indignity of serving that to your guests, yes. If you're selling that sugar syrup, no. You want to wait for natural nectar to come in and build those combs so that then there's no risk that you're defrauding anyone by telling them it's honey when it's really just sugar syrup. When do I start checking for varroa mites and what levels am I looking for or hoping to see in early spring? So if I've got a screened bottom board on my hives, as I said, first time I can go out and work them, I'm going to put a sticky board underneath and come back a few days later and just see how many mites are falling. If I'm seeing, fewer than 10 mites falling per day, then I feel like I'm in okay shape at the very least. If I'm in terms of more rigorous sampling, alcohol wash sampling, that is typically for me going to start in May for strong colonies. For a weaker colony, if I don't want to sacrifice the 300 bees, it might not be until June 1st that I do my first alcohol wash. But typically those bees have already been monitored going into the previous season, and I'm probably going to have done this spring treatment without directly looking at my mite population. Because I know that I can kill a few mites now, especially with some of these gentler treatments like the oxalic acid dribble or an oxalic acid vapor, and then reap the rewards of not having those mite offspring to fight later in the season. Do I have experience with top bar beehives? Yes, a little bit, but probably not enough to get into detail here. My one word of warning about top bar beehives is that they tend to do less well in areas that have colder winters because that horizontal configuration can lead to the bees getting a little confused about which way to go to find their honey. So unfortunately, we've seen cases where top bar beehives, the bees have sort of gone off in one direction, gotten stuck on one end, and not been able to get all the way across to get their honey on the other side. That's why I prefer a vertical orientation for my hives to a horizontal one. When do you put queen excluders on? So if you use queen excluders, and you do not have to in your bee management, I prefer not to most of the time. But when you put your queen excluders on is typically going to be when you put your supers on, as long as those supers have drawn comb. It is very difficult to get bees to draw comb when you've got queen excluders in place because the bees down below eat some nectar, they crawl up through the bars of the queen excluder, it scrapes off all of those hard-won little scales of wax, and the bees say, oh, phooey, I'm not going to come up here and do this anymore. So they don't build much wax on the other side of an excluder. Once that wax is drawn, though, you can put it on, and the bees will squeeze through it, regurgitate the nectar up above, and ripen it into honey. That's typically when you would do that. Is it possible to get more than one nuke out of a very strong hive coming out of winter? Yeah, that's a great question. So again, in that swarming and splitting class that we offer, I go into more detail, but essentially my words of wisdom on the subject are this. Before you split a colony, you need to answer the question, what am I trying to do here? Because you can take one strong colony and split it into two colonies of medium strength, and you may or may not be able to get honey out of either of those in that season. You can also take one strong colony and pull a nuke out of it, and that's going to be not a huge sacrifice for those bees. You'll probably get honey out of the big colony. You probably won't get it out of that little nuke. You can also take a big, full, booming colony, and you can break it down into 3, 4, 5 nukes potentially, and then expect to get no honey out of them, but have a whole lot more bees than you started with. On the March warm day inspection, and the bee cozy, the hive cozy, is around them. Do you open the top and check what you see? Add food and close the hive. I'm not looking at the boxes, not looking at brood. So I do generally not pull out frames if I can avoid it in that earliest inspection. But I will, under certain circumstances, like if I found that weak colony in my own apiary, I said, I'm curious about this. I'd like to see if there are eggs. I'd like to see if I can get a sense of what might be going wrong here. And as it turns out, the colony was just little, and so I'm going to give them some boosting, and I think they're going to be okay. So yeah, in the case of hive insulation or a bee cozy, you might very well wind up taking that off during that first slightly warm day inspection, but it's not a bad idea to put it back on afterwards, even though you're going to kind of wrestle it back down over the boxes, because that's going to help those bees as the weather gets colder and then warmer and then colder and then warmer. Can you give a sugar brick and a winter patty at the same time? Sure, why not? I'm sure your bees would appreciate it, and you'll get to find out which they preferred. New beekeeper, what qualifies as high levels of mites for an alcohol wash? That's a great question. So the Honeybee Health Coalition has published a Varroa guide. Betterbee's catalog on page, I think, 76, maybe it's 73, has a whole little section that I wrote about Varroa mites, and that includes the Honeybee Health Coalition's guide. And that'll tell you seasonally what is a high level that requires treatment to keep those bees healthy. I'm on the committee in the Honeybee Health Coalition that's actually revising that guide, and I can tell you that we are getting more strict about how, when people should be treating. Generally, we are recommending lower levels of mite population should still trigger treatment. So the rule of thumb a lot of beekeepers are currently working from is whenever your mites get above 2% infestation, it's time to do a treatment. I know some beekeepers who treat whenever their mites get above 1% of infestation. And so, they are perfectly happy with their results as well. Someone just did their first inspection a few days ago. There were some dead wax moth larvae around the entrance of the hive. Do I need to take action? No. As long as those bees are still alive, they will be able to displace and evict any wax moths. If you've got a lot of wax moth damage, sometimes it can sort of overwhelm the bees, and so it makes sense to go in and remove some of the damaged combs or scrape out some of those wax moth larvae and pupae. But other than that, no. A couple of larvae here and there, typically the bees will be able to evict as they re-expand and reassert their dominance over the hive. If you have a very low mite count going into spring, do you still need to treat? No. Never should you treat if you know that your mite count is low. And so if you are able to do that mite assessment and you're able to determine that your mite count is low, there's no reason for you to stress the bees and waste the money of going through that treatment. Continue monitoring and treat whenever you get to that threshold level. What is persistence and effects of apivars breakdown chemicals? Are they fairly innocuous? Yeah, so the apivar, as I said, has the active ingredient of amitraz. Amitraz breaks down very quickly, but it breaks down into these two molecules, which are sort of half of an amitraz and the other half of an amitraz, for want of a more complicated explanation. They are not something that I'd want to drink a gallon of, but they're not so acutely poisonous that anybody who eats honey that might have some of these residues in them is going to die. So it's not ethical to sell honey that you know to be contaminated with this stuff. I have seen some evidence that, especially in commercial apiaries where they use lots and lots of this amitraz to kill mites, that you can find extraordinarily high levels of it in the comb. And so there is probably some risk that could get into honey at some levels. If you are a beekeeper trying to sell your honey at the local farmer's market, that might be a point to raise, to say, hey, I don't use dangerous levels of this stuff. I rotate my comb regularly to remove any contaminants, and so my stuff is maybe safer than the stuff on the grocery store shelf. Um, Someone asks, you may have discussed and I missed it. Can you give an overview of when, why, feeding pollen substitute, and the concentration to choose? So I won't comment on the concentration of bee pollen to choose for your pollen substitute, for your protein substitute. The important thing to remember is that that percentage is generally not the percentage of pollen. You're sorry, the percentage of protein. It's just the percentage of pollen. Often the percentage of protein is pretty similar, and it's just how much of that is made up of bee pollen versus some other source of protein. I did touch on this a bit, but essentially, you're feeding your bees a protein substitute or a supplement when you want to boost their growth because they are particularly small or weak, or because you're trying to manufacture new brood and new bees so that you can then use them to do something. And typically what you're using them to do is split that colony. Only occasionally will folks succeed by giving their bees a protein substitute to make a giant booming colony and then just make a ton of honey from that colony. More often than not, I find that it sort of gets them overexcited, overgrowing, and then you wind up with a swarm on your hands. So someone has a weaker hive living in just a single deep. They're out of room and they've added another deep a couple of days ago. They put the winter patty in the upper deep. Will they be okay finding the food in the top box, or will that kill the cluster during 40-degree days? Yeah. So essentially what I touched on this a bit. If you're giving your bees food, you want that food to be as close to the bees as possible. And so if your bees are not in one of their two boxes, then they're gonna better to remove that box entirely. In this case, where you've added the extra box, as long as those bees are able to come and go and move around, that the winter patty there might be fine. In your shoes, I might even cut that winter patty into strips and see if I can't kind of smash it in between the two boxes. It might not look terribly pretty, but the bees might appreciate the food being a little bit closer. What's the best way to use drone comb? So depending upon what you mean by that question, if the question is how do you use drone comb to control Varroa mites, the process very simply is you put in drone comb, the bees make drones in them, the queen lays drones, the bees raise them. Before they get capped, the Varroa mites preferentially run into them, and then before those drones emerge, you take the whole frame out, shake the bees off, pop it into a freezer, and you kill the drones, and you also kill all of the mites. And you can do that maybe a couple of cycles in the spring. And it's not enough to control your mite population entirely, but it is absolutely enough to have an impact on it, to help to control the mite population. And so I expect that's what your question was about, and so I'm going to assume that that has answered it. Somebody says, do you recommend condensing hives? And if so, what are my insulation recommendations? So that's a good question. So the idea of the condensing hive is this idea that if you don't have a lot of ventilation in the top of your beehive, especially in winter, then moisture from the bee's breath is going to float out of their cluster and it's going to go up and it will condense inside of the hive instead of just blowing away. And that condensation acts as the process of condensation releases some excess heat, some of the heat that was inside that water vapor, and that's going to provide some heat that will help keep the colony from getting quite as cold. And the bees, of course, can also drink some of that moisture. I generally have been following those condensing hive principles in my hives. There's actually an interview that I did with Bill Hesbach, an EAS master beekeeper from Connecticut, about condensing hives, which, if I'm not being over bold, I think was a big part of sort of rejuvenating this conversation in beekeeping about condensing hives. And so if you're interested, that's a cool conversation between me and Bill that you can go and watch on the YouTube channel. But in terms of insulation recommendations, insulation of the roof of a hive is very, very, very important in the condensing hive setup. All of the rest of the insulation is of, let's say, moderate importance. So whether your walls are insulated, how thick that insulation is, just how well insulated something is, I think is ultimately much less important than making sure that you've got minimal ventilation at the top of the hive and good insulation on the roof so that condensation doesn't form immediately above the bees and drip on them. It forms towards the edges and onto those upper walls where the cluster might still be up there benefiting from the heat, but they're not going to have that water dripping on them. Jim says, I've got a very strong hive, and last check I had larvae, worms crawling on top of the frames. I'm using winter patties. Is it beetles? Inside of the frames looks good. I'd love you to send me a photo. You can send a photo to support@betterbee.com, and I'd want to take a look at it. That certainly could be small hive beetle larvae that are feeding on some of the sugar and the protein in the winter patties, although it would surprise me, that's a common problem for pollen patties, less common in winter patties, but it certainly can happen. So I would want to see a photo before I gave a definite diagnosis. What happens if you use Formic Pro below 50 degrees? Good question. So Formic Pro forms a vapor, and that vapor needs to be fanned out of the hive by the bees, or it will reach problematic levels. So if the bees are in a cluster at 50 degrees, they're not fanning their wings to blow the extra formic vapor outside, and they can get overwhelmed by it. If the formic is used when the weather is above 85 degrees Fahrenheit, the bees are so focused on cooling the hive that they can actually blow so much of the formic out that they, it doesn't kill the mites at all. Or if the bees aren't able to focus on that ventilation, too much formic can sort of overwhelm them. So it gets sort of unpredictable below 50 and above 85 degrees Fahrenheit. Not to keep plugging YouTube interviews I've done, but I interviewed Heather Brocard-Bell, who is the staff scientist up at NOD, who make Formic Pro. That's also on the Betterbee YouTube channel. And if you take a look at that, she and I talked, among other things, about the effects of being outside of those temperature ranges on effectiveness. Do I not recommend Apiguard? Yeah, so that's a great question. So Apiguard and Apilife Var are the two thymol-based, essential oil of thyme-based products that are approved for mites. They are great products. I generally don't find much use for them in the spring because where I am, by the time I can go into my hives and start applying the multiple doses of these thymol-based products, I'm already getting close enough to when I want to put my supers on that I don't feel that they are an appropriate intervention. I think it's problematic and it can get annoying if I feel that I want to add a super, but I need to wait for the thymol vapors to leave so that I don't stink up my honey. So I really like these thymol-based treatments. I really like them in the fall when I'm not worried about that same problem. If Apiguard or if Apilife Var are working for you in the spring, by all means, go ahead and use them. And in some areas, I'm sure that the weather and the honey flows line up to make that more reasonable. For me, it just doesn't work as well. What is the best way to know when to add supers to your hives? So the best way to know is when a honey flow is coming. Another really useful rule of thumb that is helpful across the board is when do I add another box to this hive? It's when the bees are using or have filled 70% of the box below it. So if my bees are building up comb, maybe I've just added a first new brood box to them and they're building up comb in that and they're filling it up with brood. Once they've filled up that brood nest, I'm going to add my supers, typically when the bees have got about 70% of the box below done. But in an established colony, when we're not really talking about comb building, typically, something like that rule of thumb is still useful to be able to say when about 70% of the frames down here are feeling pretty much full, let's give the bees some more space up above. As I said, though, with supers, I might have to put 2 supers, 3 supers on a hive, a strong hive, right before a really big honey flow. Can use of broadcast pesticides in the area of an apiary trigger swarming behavior? So use like a row crop pesticide used in the area of an apiary. It wouldn't be swarming behavior. It would be absconding behavior, which can be triggered by chemical contaminants. And sometimes when bees abscond, the queen and many of the workers fly away, they will, in a sort of half-hearted way, leave behind some queen cells and some bees. And so it sort of looks like a swarm. But what it ultimately is that colony abandoning ship. And then like maybe some bees are stuck, left behind, emerging from the brood, and then trying to make a go of things. And so that's plausible. I know that some chemical exposures can sometimes trigger that, but it's unlikely that your bees are swarming because somebody is using pesticides nearby. What are my thoughts on HopGuard? So HopGuard is another miticide. to be perfectly frank, my thoughts on HopGuard are that it is quite expensive per hive, and it is no more effective and is often less effective than other treatments when compared and used in hives under similar circumstances. So it works. I mean, it does kill Varroa mites, but other things kill Varroa mites, and I am more inclined to recommend them, especially because I, like most beekeepers, am cheap, and I don't want to pay more for something when I can get a pretty similar result from another product. If you use Formic Pro and OAV treatment, is that enough of a rotation? So alternating between formic acid and oxalic acid. Yes, as far as we know, mites have never demonstrated any resistance to formic acid or oxalic acid. And so we maintain this rotation out of an abundance of caution. Technically, those are both carboxylic acids. They're both organic acids, and they both have a very similar chemical structure. And so plausibly, if a mite developed resistance to one of them, maybe it could also develop resistance to the other. It wouldn't be a bad idea to put something like Thymol into that rotation, every other year or every year or something like that, maybe every fall, just as a way to continue to hit the mites from different angles so that the entire mite population in your hive is not being selected just in one direction. But I'd much rather have you rotate between Formic Pro and Oxalic Vapor than only use one of those two products. Can you just treat the bees a few times a year, considering that they pretty much all need treatment? Yeah, that's a great question. So this comes down to a very common question I get as a Varroa scientist, which is, do I need to monitor or can I just treat? And the answer is the absolute gold standard that will give you the best results is monitor your mite population. When you get above threshold, treat them, and then monitor again after that treatment ends to make sure it had the effect that you want. So basically continuous periodic monitoring and then treatment whenever you hit the threshold. If you don't have time to do all of that, I would much rather that you treat blind than just monitor and say, geez, these mite numbers keep going up and up and up and up. So it is worth your time, I think, to monitor, even if you don't monitor once a month, which is what I often recommend during the summer. If you can simply monitor 3 times a year, sometime in mid to late spring, early to midsummer, and then late summer or early fall, that's going to give you a lot of information about whether your treatment course is working or not. So that's my recommendation there. Is it true that we can buy Varroa-resistant queens? I had a beekeeper tell me his queens don't get mites because he buys special queens. So the 4th chapter of my dissertation is all about Varroa resistance traits of survivor stocks of bee colonies. And I've continued work and collaborations with other scientists and colleagues on that subject. There are bees that have Varroa resistance traits. There are bees who are genetically more Varroa resistant than other bees. However, I have yet to meet a Varroa-proof bee. Even these highly resistant populations I studied, if I managed them in ways that, suppressed swarming, increased brood rearing, made a lot of honey, but were very unlike the way they were living in nature, they still had Varroa problems that I needed to intervene and help them with. So yes, you can buy bees that have more Varroa resistance, and whenever those are available, it's probably worth using that as the foundation of your mite management. But if you then need to continue to treat with mites, that doesn't mean that your Varroa-resistant bees failed. It just means that they could only get you so far in that quest to have no Varroa-associated death of your colonies. How do you keep queens from laying in supers without adding a queen excluder? Yeah, so the best way to do it is to have a barrier of honey between the brood nest and the super. So the first super, if you can get that one filled up with honey, the queen is unlikely to cross to get up into subsequent supers up above that might be empty and theoretically have space for her to lay. And so, you might use the queen excluder just early in the season. You might put a super on early and have them put some of that early spring honey up there. And then even though you're adding extra space above, even if they start to get cramped down below, I find often my queens do not venture up there and they'll stick to the area of the brood nest. There are no guarantees, so I'm more likely to find brood up in my supers than someone who uses a queen excluder religiously, but I find that I can make more honey and have less hassle my way than that way. So both methods work, both methods are good, but that's generally how one would do it. What causes irregular comb shape? Oh, hard question. Lots of things. Probably not a pathology of your bees. It could just be that they are Maybe the foundation wasn't waxed well enough. Maybe the comb got damaged and they're trying to repair it. The number of different things. If you take a photo and send that to support@betterbee.com, I'd be happy to take a look at it. And in that case, I think a picture is worth 1,000 words. It might help me evaluate it. If you need more frames with comb, would you put frames with foundation only on the outside of the occupied deep? Interesting. So would you put foundation frames on the outside of a box instead of putting it on the inside? On the outside means you're disrupting the bees less. On the inside is actually going to get built out a lot faster because they're going to recognize that the lack of comb in that area, and it's going to cause them sort of more perturbation. They'll be more upset by it, so they'll put more effort into building the comb. It depends a little bit on the weather. If the colony is cold, I don't want to risk separating the brood nest and maybe contributing to the brood getting chilled. There's various schools of thought. I'm afraid I can't get into many more details than that on getting comb built. What is the title of my dissertation, and is it from Cornell, and is it available online? Says Patrick. Yes. So, gosh, you'd think I'd have a copy in my office, and you'd think I'd remember the title of the dissertation. It was only the entirety of my 20s crystallized into 4 chapters. I'm embarrassed to say I don't know. It's got my name on it. It's the only dissertation that David Peck wrote at Cornell, so you might be able to find it in the library system there. But some of the papers were already published from it. So if you just Google my name and honeybees and probably add Cornell, I bet you would be able to find some of those open access papers that we published on drift and robbing and mite transmission and things like that. Terrific. All right. So this is just somebody saying thank you. Do you use upper entrances spring through fall? Sometimes I'll leave them plugged up all year. Sometimes I'll open up that notch in the inner cover and allow my bees to come and go. I find that they often don't need that extra space, but it is certainly an option for those that are interested in giving their bees a little bit more room to travel. And can I, oh, great. So can I discuss give me an easy one to end with. Can I discuss the tension between resistance and tolerance to viruses? So this is a real distinction in disease ecology and evolutionary disease ecology, which is what my specialty is within the Varroa interaction. So essentially, what is the difference between a colony that is resistant to mites or tolerant to viruses? The key thing is the definition of the terms resistant and tolerant. Resistance to a parasite or a pathogen means that you kill it and reduce its numbers. Tolerance means you don't kill it and reduce its numbers. You can just live with having more of it in you. So bees can be resistant to mites, they reduce the mite population, or tolerant to mites, which is the mites don't harm them. Well, we know that the mites primarily harm bees by transmitting viruses. So now you can have bees that are resistant to mites, or sorry, resistant to viruses, kill and reduce the virus numbers, or tolerant of viruses. So what I think people often get confused in this, and what they mean when they try to draw this distinction is they have bees that may not be resistant to mites. They're not keeping the mite level low, but they are resistant to the viruses. And they call that mite tolerance, which doesn't really make sense. So you need to be clear that there's 2 different creatures. Honestly, it's, bees and mites and bees and viruses, but there's many different viruses. So I might be resistant to deformed wing virus and not to acute bee paralysis virus. So, there are a lot of players in this game, and if you understand that you can be either resistant, kill the parasite, or tolerate the parasite and don't have it harm you enough that it kills you, you can at least start to navigate some of these conversations about these different organisms. In colonies with high mite counts, is requeening a strategy for a mechanical integrated pest management? Yeah, that's a reasonable point. If you requeen a colony or dequeen a colony and force them to requeen when you've got high mites, is that going to help reduce your mite population? Can that be part of your integrated pest management strategy? Yes. If you requeen with a queen that is more Varroa resistant, that is also an even better way to build the foundation of your mite resistance in that colony, so that you then need to use fewer chemical treatments in order to keep them under control. Is it okay to open the upper entrance during winter if dead bees block the lower entrance? Yes, that's a great point. So if you open up the upper entrance during the winter, if the bottom entrance is blocked or by either snow or dead bees, the upper entrance may be a very valuable way for the bees to go take those cleansing flights and not have bathroom accidents. Personally, I would rather go pull out my mouse guard, grab a stick, scrape out a bunch of dead bees, knock the snow off the entrance, and then put the mouse guard back in, because I would prefer not to have that upper ventilation, because I find that works for my bees, getting them through the winter. But yes, you can absolutely use the upper entrance that way. Do wild beehives get mites? Yes, all wild beehives that I know of in regions that have Varroa mites if the region has Varroa mites, the wild populations do as well. Again, chapter 4 of my dissertation on the Arnott Forest survivor population just south of Cornell University. This is a totally feral, free-living colony or population of colonies, and they do have Varroa mites. They do manage to survive with them, in part because of resistance and in part because of their lifestyle of regularly getting honeybound and then swarming and splitting. Basically leads to brood breaks that help to control the mites as well. And all of those things together help them to survive. But yes, the Varroa mite is a devastating plague of bees. They've only been on our bees for maybe a century, and unfortunately, no matter what those bees are doing or where they're kept, they're likely to get those mites. So the question is simply, how do you keep the mites under control? And in most beekeepers' hives, under most circumstances, that involves a combination of some skillful manipulations and also using chemical miticides. As we continue to breed more and more mite-resistant bees, it would be great if 5 years from now we had mite-proof bees and I didn't have to tell anybody anything about miticides. This lecture wouldn't have taken this long. But unfortunately, mite management remains really important. And for most beekeepers, a critical component of their management strategy is chemical treatments. If you don't use an upper entrance in winter, do I recommend a notched inner cover? That works just fine, but if you don't want to have that upper entrance, you can either pull the outer cover to block the notch, or you can just take a piece of beeswax and cram it into the notch, and that's going to prevent the bees from coming and going through it. Terrific. All right. So I'm going to end with Tim saying something very nice to me. And other than that, I apologize. I've run a little bit over time. I know we had 160 people and we're down to maybe half of that. So I don't think we'll go any lower. Thank you so much. It has been a great pleasure talking to all of you. It has been really my delight. I hope that you feel like better beekeepers as a result of this. And as I said, if you enjoyed this, please join us for our next webinar. Take any of the classes that Betterbee offers. If you've got a local bee club, shoot us an email, and we're always happy to arrange to send a speaker who might be able to, to give a lecture on any subject that you might be able to dream of. So thank you so much. Have a good evening. It has been my great delight to host this webinar for you today.